The world is on the brink of a new era for manufacturing. In the coming years, disruptive innovations such as AI, robotics, autonomous mobility, additive manufacturing, and renewable materials will join together and form a new tech stack for how we make, move, and use physical products in society. The manufacturing playbook of the past will see a successor taking charge, flipping traditional best practices on their heads. New business models such as product as a service, the sharing economy, reshoring, and circularity could all become scaled realities in society. In this edition of Welcome to the Future, we focus our attention to how the tech stack for manufacturing could reshuffle and what type of companies could be prospective winners. First off, when robots become equally as good as humans to conduct a specific utility and can do this to a lower cost, higher speed, and almost constant uptime, meaning no sleeping, no breaks, no vacations, and so forth, it increases the likelihood of manufacturing companies partly switching to a business model where access is the main economic lever, not the number of units. Usership instead of ownership, in other words. Will pay for the utility a product can perform for us a lot more compared to today, where we predominantly own the products that we use ourselves to produce a utility. Think of robots that vacuum floors, clean buildings, weld metal, serve food, lift stuff, and other things. Because if usership really proliferates in society, it changes the incentive for the manufacturing companies and retailers around the world from maximizing the number of units sold to maximizing longevity of products instead. And secondly, physical products and robots need to be moved between customers much more seamlessly than is the case today in order to enable the usership business model. So when vehicles become autonomous, products will be supported by a significantly less costly mobility infrastructure and consequently one that can support a profitable sharing economy. The sharing economy has long been a promising key to lowering carbon emissions, but has not yet delivered. In my view, the sharing economy needs a next mile mobility infrastructure to really proliferate and change our collective view on consumption in general. The current last mile infrastructure does not favor a peer-to-peer system, meaning the sharing economy. And thirdly, if we have hundreds of millions of robots that can solve problems better than traditional products can, and when they are able to swiftly move from place to place to conduct this problem solving, the economic rationale to have a factory close to the point of consumption could explode. But this might not be enough, as the labor cost arbitrage that low-wage countries have on high-wage countries could still be too large. However, when companies like Figure, Tesla, Xpeng, Agility Robotics excel in their missions to make general-purpose humanoid robots and other shapes more capable and less costly than their human counterparts in factories, this cost arbitrage will most likely be broken. General-purpose robots could become the biggest product category ever in human history, enabling the building of sustainable factories in high-wage countries, and also the next big platform for physical product applications. Sort of like how Apple created the applications economy in the digital world, but now for the physical world, which is an order of magnitude bigger. And then fourthly and lastly, the thesis here paint a picture where the manufacturing complex is a lot more distributed around the world than today. In such a model, and tied to the prospective new incentive of making products more durable and renewable in a usership business model, it makes much more sense to source physical materials through a distributed model as well. Instead of using newly mined materials, it could make more economic sense to source materials from depleted products instead. Such economic incentive could lead to manufacturing companies investing into higher quality materials that can be renewed and that can be produced locally. Or in other words, renewable materials and additive manufacturing could have crucial roles in the next manufacturing tech stack. Now, having a new tech stack, which in manufacturing terms mean a new supply chain network, and having factories closer to the point of consumption are two massive challenges that won't be built in a few years. But together, they could form the groundworks for a new manufacturing infrastructure that supports circular applications, meaning physical products, in other words. Currently, our linear infrastructure does not support the systemic scaling of circular applications. Historically, an infrastructure usually needs to be in place before applications can scale and proliferate. Think roads before cars, electric grids before appliances, computers before the internet and websites, and charging stations before electric vehicles. Autonomous mobility, general purpose robots, renewable materials, AI chips, additive manufacturing, and other disruptive innovations should all be considered interlinked and part of a cohesive unit that becomes the next big manufacturing infrastructure. Over the past half century, high-wage countries have continually offshored manufacturing of goods and products. This has been exacerbated over the past 20 years as e-commerce has raised efficiency and cut middlemen out of the value chain. We have fast consumption ruling the game of manufacturing. Most manufacturing sectors out there are about just in time and deliver as quickly as possible to the lowest cost, no matter where that is on the planet. But this could be about to change. For example, the current US administration have put substantially more emphasis on making physical goods and products domestically. They've even likened the prospect of reshoring manufacturing factories and jobs back to the US with the immense power charge of the space race and putting a man on the moon. It is highly prioritized, and with the next administration likely raising tariffs for imports, reshoring of manufacturing could become one of the most relevant topics in the coming political cycles. And furthermore, we have US technology investor and accelerator Y Combinator saying that they want to fund more startup companies that are bringing manufacturing back to America. They believe that during the next decade, we'll see a resurgence in Silicon Valley startups making physical products. Now, what this all means is that we are most likely standing before an era of market disruption like we've never seen before. These exponential technologies hold the potential to transform our global economy in profound ways, even more so than the introduction of the steam engine, the car, the transistor, the internet, and even smartphones. And most likely, this era will be characterized by new market actors building new factories, new supply chains, new technologies, and new business models, together becoming the main driver of the shift from a linear economy today to a circular economy in a few decades from now. And as an investor, focusing on this new manufacturing tech stack, analyzing startup companies that drive innovation, could very well be one of the most attractive investment strategies going forward. And many of these companies need not only capital, but access to experience, network, talent, and even strategic foresight. Now, let's exemplify some of the pioneers that are building the next generation manufacturing tech stack. First off, we have NVIDIA, the big behemoth in AI. Based in the US, it is a leading designer of GPUs and AI accelerators crucial for high-performance computing. They originate from the early graphics industry and have since diversified into AI, robotics, and data centers. Their long-term mission is to power the entire tech stack, driving advances in perception, decision-making, and simulation for automated systems. And then we have US-based Ouster, which produces high-resolution digital LiDAR sensors essential for machine perception and spatial understanding. Originating from the autonomous vehicle and robotics ecosystem, Ouster has continually refined solid-state LiDAR tech to be more reliable, affordable, and versatile. Next up is Neuro, also from the US, that develops small, autonomous delivery vehicles designed primarily for local good transportation. Spun out of the Silicon Valley autonomous mobility community, Neuro focuses on last-mile delivery robots that are safe and environmentally friendly. Another autonomous mobility company is Zoox, an American company also, nowadays owned by Amazon, that designs ground-up, fully electric, driverless shuttles for urban mobility. They also hail from the Silicon Valley ecosystem and have changed traditional car design principles by creating symmetrical, bidirectional vehicles. Their long-term mission is to provide safe, zero-emission, on-demand urban transport solutions that reshape city landscapes. The next company is also from California, Tesla, the big gorilla in the autonomous mobility space. This company is mostly known for its electric vehicles, but the main story about Tesla will be about robotics, both on our streets in the form of vehicles, as well in the form of general-purpose robots wherever in society. Tesla pursues full autonomy in their highly automated gigafactories. Then we have Udelv, a very interesting company developing autonomous electric delivery vans to streamline last-mile logistics. Coming from the on-demand delivery and autonomous driving sector, Udelv's focus is on efficient, driverless cargo transport. Their long-term mission is to make local deliveries faster, greener, and more cost-efficient. Next is Starship Technologies, originating from Estonia, which builds small, autonomous delivery robots that traverse sidewalks. Their robot handles groceries and parcels safely and efficiently. And then we have Zipline, that specializes in autonomous drone delivery of medical supplies and essentials. Born out of the need for instant access to critical resources, Zipline provides rapid, reliable, and low-carbon transport. Their long-term mission is to make vital goods, meaning medicine, vaccines, spare parts, immediately available everywhere. Another delivery company is Wing, which since 2018 is part of Alphabet. Wing develops drone-based deliveries of small parcels. They aim to reduce delivery times, traffic congestion, and emissions by transporting goods quickly through the air. In the long term, Wing envisions an ecosystem where autonomous drones serve as a swift, reliable, and sustainable last-mile solution for various industries. And then we have Redwood Materials, which focuses on recycling EV batteries into raw materials. Emerging from the EV and energy storage sectors, Redwood Materials seeks to close the loop on valuable metals and minerals. Their long-term mission is to create a sustainable circular supply chain for batteries, reducing the environmental impact of resource extraction. And then US-based Impossible Objects, that specializes in composite-based additive manufacturing for lightweight, durable parts. Coming from the advanced materials and 3D printing domain, they revolutionize how strong, complex components are fabricated. And last up is Figure, but certainly not the least, which is backed by the US big tech community. This company develops AI-driven humanoid robots intended for general-purpose tasks. They blend mechanical design with advanced control algorithms. Their long-term mission is to make humanoids practical assistants in factories, logistics, and beyond. Integrated into the manufacturing ecosystem, Figure's robots could one day perform complex manual tasks, reshaping labor dynamics and increasing flexibility. And this concludes this research edition of Welcome to the Future. You'll find the written version on LinkedIn or on our website at circular.io, where you can subscribe to future editions. You can also listen to this edition through Spotify. Thank you and all the best. Until next time.